Dr. Metis from NIT Warangal. Am I audible? Hello? Am I audible, Andy?
Sir, yes, sir.
Thank you, sir. Thank you. Delay as we are traveling. Commencing the today's webinar. By Dr. Metis from NIT Warangal. Today's webinar is on afternoon about his his revision and a dictionary and different page IIT Hyderabad and Master of Technology JNTU and Bachelor of Technology JNTU Hyderabad. He worked another at Academy Sincere Taiwan and postdoc at Forensic Engineering. Worked as professional
Sir, audio is not clear.
Hello? 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 Hello. Sir, ಮೊಬೈಲ್ నుంచి ಮಾಡ್ತೀನಿ ಓಕೆನಾ? ಮೊಬೈಲ್ నుంచి ಮಾಡ್ತೀನಿ.
tool that they would do generally they will have
అప్పుడు వచ్చింది చూడండి.
it was director/d, then he would have started this meet, he had to go. And he will be back on first. But I think I was on 29th itself. So yes. In fact, yesterday also I messaged him and told he said that please convey my regards and tell that.
Hello. So sorry for the interruption. Introduction of Professor Metis. I would like to invite him, and before that, I request our Vice Chairman Akshay, Professor S. Bhaskar Rao garu, Vijay Bhaskar Rao garu, to address the gathering. Sir, sir. 1 minute, sir.
Very good morning, Annie. Hello. Hello, am I audible to all the people?
Yes, sir. Yes, sir.
Yeah. Very good morning, all of you. And I understand today you are organizing this webinar on AI and data processing. Is one of the important field. Actually, today everybody talking about artificial. Without AI, there is no field. I understand. So data, of course, data mining, data processing is biggest activities going on in this country. So people should try to understand what is data, how do you process the data using AI and other techniques. In this context, this workshop assumes importance. I request all the participants to go through the delivery lectures delivered by the expert members, so that you can understand processing of data and algorithms and etc. So I congratulate APSHI for organizing this particular thing, and I wish all the best to the conference. Thank you, one and all. Yes.
Good morning to all. I'm audible.
Yes, sir.
Yeah, thank you. My screen is visible.
Yes, sir.
So it is going to the full screen mode. So I am unable to see the chart. If anyone can you response to my voice, it's fine. Okay. So again, I'm sharing my screen.
Sir, please unmute and continue, sir. Sir, you are in mute.
Audible now?
Yes, sir. Now you are audible.
So in this topic, I want to discuss about the data pre-processing and transformation techniques. So data pre-processing is the one of the important stage in the many different type of the terminologies and domains. So you already knows different terminologies is there and different domains is there, like data mining, data science, NLP, text mining, computer vision, like this many terminologies is there. So each and every terminologies, the data pre-processing is the one of the important stage. So what is mean by pre-processing? Pre-processing is nothing but before your actual task, you want to perform some operations on your data. That operations we can call as a pre-processing methods. Before actual task means, for example, in your home, you want to make it as prepare the one curry kind of thing. Suppose you want to make it as a brinjal curry. So you take the brinjals and keep it on the stove. It is automatically prepare the curry? No. So what you need to do before preparing the curry means some ingredients you need to prepare it, like masala kind of thing, or maybe cut the onions and cut the chili or some other ingredients kind of thing. So what is our main task? Main task is you need to prepare the curry. But what you're doing before preparing the curry, you'll be preparing some kind of ingredients. So this ingredient preparation is called the pre-processing method. So the same way here also, you need to prepare the your raw data for analysis purpose. Analysis purpose means to get the better outcome kind of thing by using the some kind of techniques that is called the cleaning and transformation. Okay, so why you are adding the ingredients into that curry to get the better taste kind of thing. So here also the main goal of the here data pre-processing is, what is the main goal is, you need to improve the quality of the data. Improve the quality of the data. So that is the one of the main goal. So how you can improve the quality of the data? By using the this cleaning and transformation method, transforming methods. So in the cleaning means what is the things will come. So handling the missing data. So sometimes you not have the some kind of attribute values. So that is called the missing data. So you need to have the handling the missing the values and remove the duplicates. So your data maybe contain the duplicate kind of information. You need to remove the duplicates kind of thing. And next one is the normalize the data. So this all are coming to the cleaning and transformation to get the better quality of the data. So definitely if you are applying on this one, you will get the better accuracy of the your output. So that is the main motive of the your data pre-processing. So what are the stages is there available in the data pre-processing is, so first one is the data cleaning, data integration, data transformation, data reduction. So these are the complete stages in the data pre-processing. So mostly we are seeing the cleaning and transformation kind of thing, important thing. So now you are talking about the data cleaning kind of thing. So it is the process of identifying and correcting the errors in the data. So for example, you collected your raw data. So maybe the raw data is not perfect data kind of thing. So due to that, it will not give the better accuracy or better results kind of thing. So then what you need to do, you identify the what are the errors is there, and you need to rectify to get the better outcome kind of thing. So how to identify the errors, what type of the errors is in there. So I said just previously, maybe it is contain the missing values kind of information, and maybe it's contain the duplicates kind of information. So, or maybe it is outlier data kind of thing. So because of these things, you are applying any kind of techniques or methods, it will not give the better results. So you need to handle this kind of information in the data cleaning stage. Okay. So first talking about the missing values. Okay. So in the missing values means you are gathering the first data from the different sources. So okay. So depending on the your application, different formats of the data is available. Okay. Some people they're working on the text related data, text documents is required. Some people working on the image related data, images are required. Some people working on the tabular data, the CSV files kind of information, numerical data kind of thing available, or some people working on the video related data, video information is required. Okay. So when you're collecting the data, maybe some of the attribute values not have, means it is not contain the some attribute values, or maybe some of the rows does not have the fulfilled values, some of the values are missing. So we need to fill that missing values or fill that gaps kind of thing to get the better outcome or better accuracy kind of thing. So before that, how to gather the data? So for collecting the data, different sources is available. So one of the source is the, we can call as the, where is the data collected and stored into the some places. So that places we can call as the repositories. Okay. So here I am showing the some of the few of the repositories. One is called the Kaggle. In the Kaggle is the huge repository. In this different type of the data formats is available, like text related data, image related data, video related data, or tabular form kind of data. So many different formats of data is available on different applications. So different applications also is our medical related, or finance related, or maybe regular images kind of thing, many different kind of thing. So better you can go and search it in this repository, you can get the different type of data sets. And another oldest data set is there, that is called the UCI machine learning repository. So in this data set, it's contain the little bit old kind of data set. It's contain the mostly numerical data or categorical data is there. So I will discuss what is the numerical and what is the categorical data. So in this, most of the samples are very few samples is available, like 100 samples, 200 samples, or 500 samples only. It's not available more number of samples. The small data sets is available in this UCI repository. And some of the data sets is available in the particular who is developed their GitHubs. Okay. For example, I developed my own data set. So I want to, instead of keeping this repositories, I have the one GitHub is there. In the GitHub repository, I will copy my entire data set. So that will be allowed to access the publicly. So like that, depending on your application, that related data sets is available. Like for example, if you want to work on the face related kind of data, or ECG kind of data, or EEG kind of data. So one website is there, that is name is called the Physionet. Okay. So you can go to that website, you can download the either face related images or ECG, EEG related images. Or some other kind of website is there. One is you can have the ImageNet data set is there. So this is the images related kind of data set. All are natural images, like car related images, flower related images. So like that, total 1000 classes of the images are available, 1000 different classes kind of thing. Okay. So here I'm showing the some of the government maintaining the repositories also is available. So initially, first stage is you need to collect your database or data sets from the repositories. Okay. So this is the first one case. Then after that, you need to apply the what are the pre-processing techniques is there. Okay. That pre-processing methods you need to apply it. So first one is you need to import the data set using some libraries. Okay. So here mostly this all what are the terminologies, like data science related, NLP related, or text mining related, or medical imaging related, or computer imaging related. So mostly you can using this applications on these terminologies, they use the Python only. So it is easy way to do the operations on the data set. because in this Python many predefined libraries are available. Okay, so here for importing the data set, some libraries is required. So the libraries are, we can call as a NumPy and Pandas. So NumPy is used to perform some operations on the arrays and matrix kind of vectors kind of operations, and Pandas they will use to read the files related kind of thing. Okay, so maybe your data is contained in the Excel sheet or CSV file. So first you can load that file. Okay, so that is, you can use the importing command from the data set. So how to import is using the Pandas. So here my database is there in this CSV file. So the database contain the data.csv file is there. Okay, so in this I have the data is there. So that how can I am reading is with help of the PD is nothing but what, Pandas object. So object dot function name, read underscore csv is the my function name, means it will be read the csv files. Okay, so that is contained in the variable data set. So once I am displaying the what is contained in the data set, so like this it will display on the screen. So total here 10 samples is there, number of samples are 10. So how many attributes is there? One is country, age, salary. So for example, your country is the France and age is 44 is there, his salary is 72,000 is there, he will purchase the house or not. So this is the your class. So class contain the only two values kind of thing, yes or no kind of thing. What are these three? These three we can call as the attributes. So these three we can call as attributes. So based on these attribute values, whether I will purchase the house or not, we need to conclude it. Okay. So first you are here, what you are doing, you are importing the data set. So your data is available in the data.csv file. So for importing means you are getting the data, you are using the pandas library. So in that case, you can use the read function kind of thing. So read underscore csv. So that will be contain the csv file information. Next, I said format. So data is not available only CSV format, many different type of formats is available. So how to access? So previously how to access the data for CSV file? So object is pandas pd dot read my CSV file, read underscore CSV, the file name you are giving. Okay, but my file is not CSV format, maybe another formats is there. So that what are the formats is there, I will show here. See here, for example, it is Excel format is there, or maybe it is the hdf or html or jsn, like different formats is there. Only how to read it, for example, I want to read the html file. So pd dot read underscore html, then you can give the file name. Okay, the file will be read. So this is the how to load the data into the your workspace. Okay, next in the we are talking about the first pre-processing technique is the cleaning related. So in the cleaning, how, what are the issues or what are the challenges is there? One is dealing with the missing data values. Okay, so one of the basic or to handle the missing values is simply you can remove the where is the missing data is there, that particular row you can remove it. That is the one way. Okay, so another way is we can replace the where is the missing value is there, the missing value replace with the mean of the entire attribute values or mode or median of the entire attribute values. So this is the one way of handling the missing the values. Okay, so now you can see here it is audible or not? I am audible? Okay, so once you are loaded the your CSV file, but the file is contain the what type of the information. So how many rows, how many columns is there, and how many values is contained, how many null values is there. So that will be with help of the information is the function. So with this help of this function, we can get the all the information related to the how many data entries is there, and what are the values is contained, it is contained the how many null values kind of thing. So for example, here information what you giving 10 entries is there, and that is start from the 0 to 9. Okay, so total 4 columns is there. Out of these 4 columns, 3 are your attribute related and 1 is the class related. So what are the attributes is there? One is the country, another one is the age, another one is salary. This is the related to the your class. So total 10 rows is there. So country contain the 10 values, means it is each row contain the value. So how many null objects is there? Means how many missing value? Null object is nothing but missing values, 0. Next, age attribute is there. Age attribute is contain the 9. How many null values is there? 1. And salary is contain the how many values? 9 values is there, means how many missing? 1. So your class labels also, how many is there? 10 rows, 10 class labels is there. There is no missing kind of class label, so that is 0. Okay, see here, previously you can I is showing that one. So here 6th row 1 is missing. Here third attribute 1 is missing. First attribute how many values? 10 values is there. Second attribute how many is there? 9. 1 is missing. Third one how many is there? 9. So in case of class labels, 10 labels is there. See here the same thing, 10, 9, 9, 9, 10. Okay, so this is the missing values identified from the your loaded data. Okay, now here where is the missing is not giving, just it is giving the just how many samples it is contain that attribute. Okay, that information is given. For example, where is the missing value is there, you want to know, you can use the method name is called the isNA function that will give the where is the missing values is there. So in that place it is given as a true kind of thing. Okay, so you can check the your original data set. So 4th row 3rd column and 6th row 2nd column is there. Okay, so mostly what will happen, 4th row 3rd column is needs to give the true value, and next one is the 6th row 2nd column needs to give the true value. So see here data set dot data set is contained my object, the function name is isNA. So where is the null values is there, in that position it will give the true kind of thing. So 4th row 3rd column, see here it is given the true, and 6th row 2nd column it is given the true, means these two places it have the null value is there. Okay, so next you want to count it how many null values is there based on the attribute. So in that case you can use the function is called the sum function. Okay, so dot here finding the null values, dot you can use a sum, so it will what will happen, it will give the count kind of thing. So each attribute how many null values is there, that count will be give. See here a dataset dot isNA function means is null function, and sum how many null values is there, you can give the sum value. So country attribute contain the 0 null values kind of thing, age contain the 1 null attribute, and salary contain the 1 null attribute value, purchase 0. Okay, so like this we can identify the each attribute how many is there. So here it is giving the total all attribute values. Suppose you want only particular attribute contain the null value, means you need to specify the that attribute with help of the function. So that is called the see here you can use the age or salary attribute, you can give that, you give the particular age related how many null values is there, how many salary values null is there. Next, to drop the null values, I said you can remove the where the missing data is there. One of the ways to you can remove the null values. So drop either row wise or column wise, you need to drop it from the missing data. Okay, so this is a basic method. So where is the missing values data is that, simply you can remove that missing values data, that is either row related or column related kind of. So for example, you can see previously 4th column, 4th row and 6th row both are having the missing data is there. In the fourth case, third column have the missing value. Sixth case, second attribute have the missing value. So now data set drop NA, drop nulling values function you are using. So here fourth one is removed and sixth one is removed. Okay. So this actually you can see this is the original data. So after applying the drop NA, then the corresponding fourth one, because it is a null value, and sixth one here also null value is there. The both the rows will be information will be removed. Okay. So this is the removing the data, but removing the data is not the correct solution. Maybe sometimes you can lose the some kind of important information which is have the other attribute values. Maybe here fourth one have the remaining attributes have the values is there, country and age, and maybe this sixth row contain the country and salary is there. So if you are removing the rows means maybe you can have the chances is there to lose the information. So instead of removing the rows or columns, we need to replacing the null values with the another kind of information, that is using the mean, median, mode kind of the techniques methods. Okay. So how we can replace it? You can see here means for example mean case, what do you need to do? So where is the missing value is there, that corresponding attribute values mean you can calculate the mean value placed with the missing value. So here you can see, so fill NA function is there, means fill the null values kind of thing. So that will be filled with the which type of the technique, with help of the mean. Okay. So we can calculate the mean of that attribute values and fill with that value. So for example here original data you have the this null value is there. So what we'll do, this is the attribute belongs to salary. Okay. So calculate the mean of all these values. So what you're getting the mean value replace with here. See here, for example now you can see fourth row, third column. The same way here also original data is contain the null value. So what you need to do, calculate the mean of the all the these values of the attribute age and replace the that null value with the mean value. Okay. So this is the one way of covering the or replacing the uh, particular missing values or null values. So one mechanism is simply removing the rows and columns kind of thing. But if you are removing the rows and columns, sometimes some other attributes related in important information maybe you can lose. To avoid that one, you can use the calculate the mean, median or mode, any one of the technique you can apply to replace the null values is the corresponding mean or median or mode kind of thing. Okay. So this is the particular replace, and here you want to go any specific kind of attribute also you can use it. Okay. See for example here age only you want to replace it, and salary only you replace it, you can specify the age and salary kind of thing, or maybe you can replace with the all the values here in this function where the null values is there, all are replaced with the mean. You here in this case you need to specify the each attribute wise, for example first attribute age is considered, then fill the null values with help of the mean, and second another attribute where is the salary attribute is there, in this case any null values is there, so fill the null values of that attribute based on the mean. Suppose if you want to use the mode, you can use mode here, no need to go for the entire data set follow the same kind of operation, you can use the any column specific means attribute specific operation also you can apply it. Okay. So this is handling the missing values or null values. So it is clear. I am full screen mode, but I am unable to see the your comments or chart kind of thing. Okay. So this is the cleaning related kind of thing, how to handle the missing or null values kind of thing. And next we can how to remove the duplicates, and that we can see the next coming slides. So now your data is there. Okay, so normally if you are doing for the any AI or machine learning kind of techniques, you apply on the data, so you need to have the data is there and corresponding output. So corresponding output is there. So in this case, what is the data? This is your data. What is the output? This is your output. Output is nothing but the class labels, which class it is belongs to. So now data set is contain the complete this table. I want separate the my data and separate the class labels. So how to separate the data and this class labels? So data we can call as the independent variable, and class labels we can call as a dependent variable. So how to separate it, independent variable and dependent variable from the entire data set? So that we need to discuss now. So divide the data set into the dependent and independent variable. Okay, so here how to divide the independent and dependent variable is you need to first read your data file. Okay, then you can split the where is the data is there and where is the dependent variable is there. So that is I lock variable function they use it. So that I will show here. Suppose first you are reading your data, means loading your data. So this is my data set. So in this case, what is the independent variables? Total how many samples is there? The number of samples is 10 samples. This is your total number of samples data. So each sample contain the how many attributes? 3 attributes, means 3 feature values we can say, or attributes or properties. These all are same. Okay, and last one, this is called the class label or dependent variable. Now I need to split it my data set into the independent variable and dependent variable. Okay, then how can I split this? Using the ilog command in the pandas. So here total data set is contained the this object ilog colon means all the rows included. Which attributes include? 0, 1, 2. Start from the 0. So country is the 0 attribute and age is the first attribute and salary is the second attribute, and this is the third one is the class name. So I'm asking here, I use the function ilog, take the all the rows of the zeros attribute, first attribute, second attribute, means it will come up to here. That will be stored in the variable x. Next y is there. Okay, now x is the what? It is the independent variable. Y is the dependent variable because it is the output labels. So what I am using the same function, ilog function you are using. Take the column means all the rows of the your third attribute. Third attribute is nothing but purchase because it start from the 0. Okay, so like this you are splitting the your total data samples into the where is the your data is there, where is the class labels is there. Okay, so this normally colon what will do, select all. Maybe it is you are giving the rows means rows, and maybe you are giving the column means columns. Okay, and this parameter, this is there, this in this square bracket what you are giving the, it will be select the multiple rows or columns depending on what you are specifying. Okay, so how it is there? First one indicates that it is indicates the rows related, it indicates the column related. Okay, see here, row selection, column selection. So rows selection, either you can use the colon to select the all the rows, or maybe you can specify the particular rows kind of thing using this bracket. In column case also you can use the colon to select the all the columns, or maybe you can use the square bracket to select the particular column. Okay, so that you can split the your dependent and independent variable. Okay, see here, this is my full data set. So in this data is there, labels is there. Okay, so labels, I said data is nothing but the features or attributes kind of thing. and our labels is nothing but your target means your output are dependent variable. The features are independent variable. So you need to separate it. For separation, what you are doing, just you can use the alloc command. So specify the rows and specify the columns, how many you want. Then it will separate row and column. So this one way of the separating the independent and dependent variable. But here one more thing is there. Suppose your task is the classification task. In the machine learning, two type of techniques is there. One is called the classification. Another one is the clustering. So classification they will call as the supervised learning methods. It is called the unsupervised learning.
Slides are not visible. Sir.
So what is the difference between this supervised and unsupervised learning methods is, supervised means it is contain the class labels. Contain the class labels. Unsupervised means unlabeled data. Unlabeled data. There is no labels here. Okay. Hello. Move కావట్లేదా? అవునా? ఏ స్లైడ్ దగ్గర ఆగిపోయింది? నల్ వాల్యూస్ రిప్లేస్మెంట్కి వెళ్ళారా? ఒక్క నిమిషం. ఓకే, మేబీ అది ఆటోమేటిక్గా డిస్కనెక్ట్. సో నల్ వాల్యూస్ ఇస్ క్లియర్. ఓకే ఓకే. Yeah. So here I'm showing the how to handle the null values. Okay. So first one is simply you can remove the particular row or column where the null values is there. So but that is not correct way to remove the null values kind of thing. Remove the null values, because when you're removing the that particular row or column, for example here null value is there, 4th row, 6th row also null value is there. These are the null values. Okay, means that is the missing data. There is no data for that particular attribute values. So what are the attributes here? Current, age, salary, these are we can call as the attributes or features or properties. Okay, and this last one we can call as the it is also attribute but is related to the class label. Okay, so here one way I said you can simply remove the where the null values is that the particular row or column you can remove it. But when you are removing this 4th row, what will happen? This row contain the remaining attribute values is there, and 6th row contain this attribute value and this attribute value is there. So maybe sometimes you are missing the important information if you are removing the rows and columns kind of thing. So that is the not the correct way. Instead of that one, you can use the mean, median, mode kind of techniques. So what you will do, mean, median, mode, any option you can use it. For example, you are using the mean, then you can see here the fill null values of given the data set using the mean. So where is the null values is there, that entire corresponding column, calculate the mean value, that mean value replace with the null values. So for example in the 4th row, 3rd column null value is there. So 4th row is 4th row, 3rd column. So this entire column, calculate the mean of this entire attribute values. Once you are calculating the attributes, you can get the mean value. So the mean value 6377 point something is there. This value replaced with the where is the null value is there here. The same way previously here the 6th row, here null value is there. Okay, so this will be you want to replace with the particular value means this entire age attribute. Okay, so this entire age attribute you can calculate the mean of the values. So you can get the mean value, for example, here is 38.777 something is come. This value replaced with here. You can see here 6th row age attribute is replaced and this one is replaced. Okay, so either you want to use it mean or you want to calculate the mode or you can calculate the median. Just you can call that function and replace is automatically replace the that corresponding value. Okay, so this is the one way of replacing the missing values kind of thing. Or here in this case entire table or entire data set you are applying the same operation, means based on the mean only you are replacing the null values. If you don't want the same for the each and every attribute, you want for the specific row, specific column, you want the specific kind of operation, then you can give the each individual filling criteria. So fill any null values for attribute age, you can apply the mean kind of thing. Another attribute salary, fill null values based on the mean, or you don't want mean, you want to apply the mode, you can apply the mode or apply the median. Okay, these are handling the null values. Next, for example, this is the data cleaning stage. One is handling the missing or null values, and another one is the removing the duplicates also is there, that we can see the coming slides. Before that, we have the data is there. This is data. So what I said, we have the attributes is there and final one label is there. So I want separate this attributes data and corresponding class label data. So this label data we can call as the independent dependent variable. So now my screen is visible. So this is dependent variable, and this remaining attributes we can call as a independent variables. So that is you can simply can call as a input data. This we can call as a output data. Okay, so now I want to separate this independent variable data and dependent variable data. How to split it and how to separate it? So that we can use the ilog command. So in this ilog command, what is there? So first indicates the row related. Okay. So row, want to select all the rows, you can use the simple colon button. So colon indicates the select the all rows, or you want rows kind of thing in the square bracket, you can specify the row number to you can specify. The same way column, you're using column means it will be select the all columns, or you want to specify the specific column means you specify the column start from the 0 1 2 3. Here also row start from the 0. Okay, so it will be select the only 4 columns kind of thing. Okay, of all rows. So that is the you can use the command ilog kind of thing. So now I want to separate the here. What I need to separate in this case, what is the dependent variable, what is the independent variable? So these 3 attributes are your data samples, that is called the independent variable. First one, last one is the your class names, means label kind of thing, that is the dependent variable. So I want to separate this kind of data using the ilog command. See here, so dataset.ilog. So here colon means indicates the what, first option indicates the rows related. So how many rows you are selecting? Colon means what, all rows you are selecting. And second one attribute, second values represent the what, it is related to the column related. So how many columns you are selecting? First, second, third. So country, age, salary, these 3 are selecting. These 3 of all the rows you are selected, that will be stored into the variable name x. Now x is what, independent variable or input data. And next same way, so first rows means all the rows you are selecting. Which columns are selecting? Only third column. Third column means what, here purchase, because it start from the 0 1 2 3. So third is purchase. Purchase is nothing but is what, class labels. Class labels means what, output data. So output data means it is the dependent variable. So where it is stored, the dependent variable is stored into the y. Okay. So now splitting is happened for your total data and corresponding labels are separated. Okay. So like this, initially how the complete data is there. Now the attributes, where is the independent data is there separated, where is the dependent variable is there, you separated. Dependent variable. Okay. Now you need to learn in the machine learning, basically two type of learning methods is there. One we can call as a supervised learning method. Another one you can call as the unsupervised learning method. So what is the difference between this supervised and unsupervised learning methods is, where is the labels is there, then we can call as a supervised data. Unlabels means there is no labels, that is called the unsupervised learning methods. Okay. So supervised we can have the classification problem. Unsupervised they will call as clustering problem. So labels means, now can you tell me here the target is nothing but labels only or dependent variable. So this is a supervised or unsupervised data? Any answer? Maybe you can unmute and you can give your responses. Okay. So here I said it contain the labels. Labels is there means it is the supervised data. So when you're talking about the supervised data, basically two type of data sets is there. One is called the training data set. Another one is called the test data set. Okay. So normally which is the standard data sets is there. So in the standard data set, they will give the training samples and testing samples separately they will give. So this is a training sample, this is a testing sample, and there is a training sample corresponding labels, this is the testing sample corresponding labels. Like that they will give separately. Suppose they're not giving the training samples, testing samples separately, then what you need to do, we need to split it. See here, these are the training samples data, and this is the corresponding labels of the training samples, and this is the testing data and corresponding labels. So like this we need to separate it. Okay. Then how can I separate it? You can use the train test split function, we can use it. Okay. With help of this train test split, we can split the training and testing kind of values. Okay. So that we can see here how to split it. For example, my database link is here. So data set. So now you are reading that URL. Previously you are taking the direct file name. If it is a file, you give the file name. But I am not have the file name, have the URL link is there. So directly instead of the file name, you can give the URL link. See here, URL link is given. Next, so how many columns I need to select it? This one, this one, this one, this one. These are selected as the columns. Okay. Now I am just I'm displaying on the screen of my 10 samples. It is 10 samples with which attributes? These attributes. So total 10 rows. So what are my attributes? Bedrooms and bathrooms, square feet living area, square feet LOT, and floor. How many floors is there, and what is the price for the house? Okay. So this is the my data kind of thing. Now I need to separate the or I want to split the my samples. So how can I split it the samples? First you can split into the data. Okay. Means labels in go to the one place and data is another place. So that you can split it, either you can use the ilog command or loc. See here. So based on these features, I am selecting all the rows. So previously you can give the column numbers. So column numbers, where it is there, I stored into the one variable features, then just I am passing that variable, or you can give the column numbers also, it's fine. So here what is the information will be stored? Only features related. Features related means what? up to here, means up to independent variables it will be stored. These all are independent variables. Next, this is called the dependent variable. So dependent variable, where it is stored? Y variable. So only dependent variable means my class label or outcome or dependent variable will be stored in the variable y. So now what you did, this is your data set. You have separated the your independent variables and dependent variables as you seen previously. But now what you need to do, you can split the your training and testing samples along with the class labels. Okay, so that case train test split function is there. So in that split function you can pass the your input independent variable data and dependent variable data, how many size you want, how much training size you want, means how many samples want as a training samples, 50% of this data or 70% of this data, you need to specify it. Okay, you can see here my function name is training testing split, means for example 100 samples is there in the data set. So how many attributes? 6 attributes is there. These are independent variables, and last attribute, 7th attribute is, it is a dependent variable. So I separated. Now in this 100 independent variables data, of means 100 cross 6 is there, and what is the independent variable? It is also contain the 100 cross 1. Okay, now in this, how many training samples I need to split it, how many testing I need to split it. For example, here training size is 75%. So 175% means 75 samples are going to the training, and remaining how many is there? What are the 25% is going to testing. The same way, the corresponding dependent variable also you need to separate, because 100 cross 1 is there. So what is the 75 cross 1? Labels are come to the training, and 25 cross 1 comes to the testing. So now you can see here extrain. What is content? Data. Okay, extrain contain the data. So X test means it is contain the training data of the 75 cross 6 samples, and X test is the test sample. What is there? 25 cross 6. Y train, the training data corresponding labels, how many? 75 cross 1, means class labels data. Y test, how many? Remaining 25 cross 1. So now training testing corresponding labels splitted, means separated. Then you can apply your machine learning techniques or methods to do the any kind of algorithms. Okay, this is the training testing splitting kind of criteria. Okay, this is a data splitting. Now come to the our what are the stages is there. So suppose sometimes your data is contain the different values. I said you see the CSV file previously. Okay, see here, this is my data set. Okay, so age salary is there. So in this case your missing values filled, that is the null values are filled, but you can see country one of the attribute, age is also one of the attributes, salary is one of the attributes. But age and salary contain the what type of the information? Numeric values. And what about country? It's contain the label related information. Okay, so this type of the data we can call as a categorical data. Okay, so when you are going for the your algorithms, your algorithm or method, the machine learning or data science, whatever it may be, we only go for the numeric kind of data only. But how it is handled like a categorical data, you convert this categorical data into the numeric values. Okay, so you can convert the categorical data. Categorical data means like this label kind of data, France, Spain, Germany, like this, what is there, that is the categorical data, labels kind of data. So that what is the labels means names, convert into what? Numeric. So how to convert into the numeric is, we have the one library is called label encoder. Okay, so with help of this label encoder, what we will do, it encoding the labels or categorical data to numeric values. So it will be maybe start from the like 0, 1, 2 like this labels will give. So how many type of values is there in the country? 3 type. One is of France, another is the Spain, another is the Germany. So each value assigned as a one number. For example, France is given 0, Spain is given 1, Germany is given 2. So now this label data converted into the numeric values. So with help of the label encoder function. So that is available as a predefined function objective kind of thing. So it is a class. Label encoder is the class that you are importing from the scikit-learn libraries. Okay. So for this class, next you can create the one object. Okay. So what is the object is LE encoder. LE encoder. Okay. So with help of this object, you need to convert the categorical data to the numeric values. Okay. Then how to convert this? I will show here. So this is your original data. Now converting LE encoder dot fit transform function. So this I said object. So this object belongs to the which class? That is belongs to the label encoder. So from this class you created object. Normally how to call the functions? Object dot function name. Okay. So what is the function to convert the label to the numeric values? Fit transform function. So fit transform. This function will convert the numeric values to the labels to the numeric values. Okay. So where is there? That is there in the X attribute. Okay. All the columns, which is the attribute? 0th attribute. So what is the 0th attribute? Country attribute. Or maybe suppose salary also like values like this is there: high, low, medium, poor, like this is there. Instead of the numbers you have this is there. Then what you need to do? L encoder dot fit transform function. So our data is there in the X variable. So iloc colon all columns, all rows related. So what is the salary is the attribute number 2. Then you can give the 2. Then what will happen? This all high, for example, high is given the one unique number 0, 1, 2, 3. So where is high is there? The I will be replaced with the 0 values. Low will be replaced with 1. Medium is replaced with 2. The same way here also the country what is there? 3 types is there. I already told: France, Spain, Germany. So France may be given start with 0, 1, 2. So now the output of this table, how it is look like? So country contain the these labels to the numbers, like these numbers are generated. See here. So this is called the label encoder. You can convert the categorical information to the numeric values with help of the label encoder function. Okay. So this is when your data set sometimes maybe contain this type of the mixed information kind of thing. So our approaches or methods which is related to data sets or machine learning is not deal with the categorical data. Categorical data means label data. So it will be only deal with the numerical values. Okay. Then you can convert into the this labels to the numeric values. Okay. So like this, the converted France is given the number as a 0, Germany is given the 1, Spain is given as a 2. So every place it is replaced with a 0, 1, 2 kind of thing. Okay. So this is a one way of replacing the categorical values. Next one is a noisy data. So already missing values you can see. Maybe your data contains some kind of noise related kind of information kind of thing. So maybe because of this noise information, maybe you can your algorithm or method give the more errors kind of thing. Means accuracy will be decrease. Okay. So how to handle the noisy data? So that is we can different techniques or methods are available. One method we call the binning method. binning method. Okay. So binning method, what will happen? For given a data, it divided into equal segments, means equal groups kind of thing. Means all the bin contain the same number of samples. Okay. So that each divided into groups kind of thing, that we can call as a segment. Then each segment we can smoothening this segment and replacing with the particular values, that is called the mean or median or boundaries kind of thing. Okay, based on that we can handle the noisy information. So that is here the one of the technique is called the binning method. So binning method, what will happen? For given a data, it will divide into the segments. So each segment contain the equal number of samples, almost the same sample number of samples are same for each bin. So that will be smooth or replaced with the values. Either you can use the mean at boundary values or median also. Okay. So how they will do it? For example, you can see here smoothing by a bin means you can calculate the all the values. Bin is some values is there. So these all the values replaced with the mean value. Okay. Or maybe if you want to go for the median, then all the bin values replaced with the median value. Or smoothing the boundaries means it is the min max values. So all the values will be replaced with the minimum value and maximum value. So which is the closest is there, that is converted to either is closest to the minimum, then all the values will convert into the minimum values. Which are the values closest to the maximum, then all the values convert into the maximum value. So I will see the one example. So this is your data. Okay, this is your samples. Okay, maybe it contains the noisy information kind of thing. So I apply the binning method. What do you need to do? First you can apply the segments kind of thing. So each segment contains the equal number of samples. So I divided the 3 bins, means 3 segments. So each segment contains the how many samples? 4 is there. So total how many? 12 samples is there. Okay. Now I can use any one of the technique, either smoothing by bin means or median or boundaries. I need to remove the noisy data. Okay. So for example, by mean. So by mean means what I said, all these bin values are replaced with the mean of the all the these values. Okay. So what are the mean of these values? 15 plus 9 plus 8 plus 4. Okay, divided by the 4. Okay, what you will get? It is get the here 24 plus 8 32 36 by 4. So it will get the 9. So bin 1 next contain the what values? The 4 values replaced with the 999. Same way bin 2. So bin 2 21 plus 21 plus 24 plus 25 by 4, because mean base we are going. So in this case, what is the mean will get? 23 you can get. So all the 4 values replaced with the 23 23 23. Similarly, bin 3, same mean you can calculate, all the values replaced with the mean. Means here you are doing the smoothing, means remove the noise based on the mean values. So these are your original values. Okay. After dividing the bins, 3 bins, it's up to you. If you want 4 bins, you can take it 4 bins. Each bin consists of a 3 values. Okay. So how many bins is up to you. So first bin, calculate the mean. I said already shown the mean value is 9. Then all the values replaced with 9. Second bin, mean value is 23. Then all the values are replaced with 23. And third bin, it's the mean value is 29. All the values will be replaced with the 29. So this is the one way of smoothing the your noise information. Next, another one is there. Here you can see median. Instead of the mean, you can calculate the median and all the values replaced with the median value. Next, you can see the smoothing by boundaries. Okay. So smoothing by boundaries, what I said, it follow the mini max value. So which are the values near to the minimum is there, that all the values replaced with the minimum value. Which are the values near to the maximum is there, that all the values replaced with the maximum value. Now you can see in the bin 1. So I apply the boundary smoothing kind of thing. So here bin 1 contains these 4 values, 4, 8, 9, 15. So which is the minimum value? 4. Maximum value 15. So now 4 is near 4 only minimum value, 8 is near to 4, 9 also near to 4, and maximum value 15. It's not near to the minimum, so it is 15 is the bin 1. Now come to the bin 2. So what is the minimum value? 21, maximum is 25. Okay. So first minimum value is 21. So next value 21 also near to the 21 only minimum value, and 24 is near to the maximum value. So 24 replaced with the 25 and 25 replaced with the 25 maximum value. Next bin 3. So bin 3 minimum value is 26, maximum value is 34. So minimum value 26 is near to 26 only, 28 also near to 26 only, 29 also near to 26 only, and 34 is the near to maximum value 34. So like this you can replace the in case of boundary smoothing you can replace the minimum maximum values. Okay, so like this you can see here this is based on the mean. See here, you check it, all are same values you are getting based on the boundaries. Okay, so this is the smoothing or remove the noise kind of information. This also comes under the pre-processing under the data cleaning. So data cleaning, one is remove one is handling the noisy remove the one is handling the incomplete or null values kind of thing. Another case is that handling the noisy data, handling the categorical data. Okay, so another way of handling the noisy data is one is using the this binning mechanism one way. So another way mechanism you can use the regression kind of thing. Regression mechanism. Another one you can use the clustering kind of thing. So handling the noise data, one is a binning mechanism, another one is regression mechanism, another one is a clustering mechanism. So binning already we seen. Next you can go with the regression mechanism. So normally there. So in the regression types is there, linear regression, multilinear regression, like that is there. So what is the aim of the linear regression or multilinear regression is, so here we have the independent variable is there. If a simple linear regression, one independent variable, one dependent variable is there. It will show the or find out the relationship between the independent and dependent variables. Okay. So in that case, you can use the in the simple regression, you can use the least square method, or maybe you can use the gradient descent algorithm to construct the one line. So how to construct the line is all the samples will be go with the that line in such way that you can construct the line. Means most of the samples is the middle. You can construct the one line kind of thing. So this is called the regression line. So in this, for example, you are using the least square method. So they will use the based on the mean only they will do it. Okay, mean means all the samples middle only. So then definitely the line will be covered the all the middle points of the your samples. Okay, so like this you can construct the line. So what happened? These all are represented with this line only. So this is the regression concept. Using the regression also we can smoothing the data with the help of the constructing the this regression line. Next, another one is the like clustering kind of thing. So here the samples is there, like this samples is there. Then clustering is nothing but you are make it as a groups, okay, segments. So is the process of grouping the data objects based on the some similarity techniques. You make it as a group. So like this, you have the data is there. Then you apply the clustering. What will happen? So in that case, which are the objects are based on the similarity metrics or distance metrics kind of thing, they make it as a group. So when you apply the clustering, what will happen? This is comes under the one group, this comes under the another group, this comes under the one group. So like that, three groups will be formed. This is C1, this is C2, this is C3, group name C given. So here these groups we can call as the clusters. Okay, so we will make it as a cluster group, and you can apply the what your technique you can apply. So based on that we can avoiding the some kind of noise information. Okay, so this is the handling the noise information by using the binning mechanism, or by using the regression model, or by using the clustering mechanism. Okay, so data cleaning, One is handling the missing data or null data. Another one is handling the nice data, nice information. So nice is one is binning, another one is cluster, another one is the regression. So next, what is there? You need to remove the duplicates. For data cleaning, another approach is remove the duplicates. So for that case, you can use a simple command. You can drop the duplicate function, then automatically where the duplicates lines is there, that information will be removed. Okay, so that is the removing the duplicates. Drop underscore duplicate function is there, so it will be remove the duplicates. Another way is you need to avoiding the any redundancy information or irrelevant information kind of thing. We need to go for the dimensionality reduction kind of methods. So that is the dimension reduction method. What is called the feature extraction method is there, that is called the transformation and projection concept they use. So the famous method is called the PCA, principal component analysis. Okay, so with help of this dimension reduction method, we can remove the duplicate kind of information, means redundant information, or maybe you can use the simple, if it is a tabular data kind of thing. So in that case, you can use that this drop duplicate function. So automatically it will be remove the duplicate values. Okay, so this is related to the data cleaning. So in the data pre-processing, so one is data cleaning is completed, next to data integration. So in the data integration means it will be merge the different source of the data. Okay, different source or different formats of the data. So maybe your data is the like a single vector kind of data, or matrix kind of data, or maybe image related kind of data. So all the data you can using the fusioning method, means combining. Fusion means combining. You can like a fusion techniques or ensemble techniques is there. With help of that one, you can combine and you can use the your data. Okay, so that is the data integration. Next, we are talking about the data form transformation. This is important. Here we are talking about the mainly data cleaning and data transformation. So we discussed it is converting the data into the particular format to easy to understand or easy to solve your problem to get the better results. Okay, so why we are going for the data transformation? So it involved the data to into the format suitable format to get the better accuracy. Okay, so what are the basic techniques is you can go for the either normalization of your data, because you have the different source of data, different columns or different attributes is there. Each attribute contains some values. The values ranges from the different values is there. Okay, maybe you can see the salaries start from the 10,000 to maybe 1 lakh is there, or maybe ages start from the like 10 to maximum 50 is there, or maybe another kind of like a country kind of is there, value 0 to 10 is there, or 0 to 5 is there. So here the ranges values is lot of variation is there, one attribute value to another attribute values. So we need to bring the all the values into the some particular range kind of thing. So in that case, you can apply the normalization technique, or maybe you can go for the standardization technique. So here we get different approaches is there. We can use any approach to do the data transformation kind of thing. So I said it is involved to convert the data into the particular suitable format to get the better accuracy or better performance. So how to bring it is using the either normalization techniques or standardization techniques and discretization techniques. Okay, so that will be helpful to bring the all the data into the particular range of values. It will improve the performance of the your data. So here you can see the normalization is the values bring particular range of the values. So that is 0 to 1 only, it will bring the all the values. So for that one, what you need to do in the normalization, simple normalization kind of thing. So this X indicates the total number of samples, subtract from the minimum value, and that is the max minus minimum value. Okay, so this is a simple normalization kind of thing. And standardization is you are subtracting the all the values, the mean of the value subtracted from the all the values and divided by the standard deviation of the that one. So this is also bring the values from the 0 to 1 only. So this also you can call as a just score. Okay. So to bring all the values into the particular range, we can use the normalization, or you can go for the standardization kind of thing. So this normalization standardization is in the Python scikit-learn library available as a predefined functions classes, so that you can import and you can use it. So already you splitted data is there. Then the splitted data, what will happen? Converted into the particular range of the values. Okay, or it will be changed the data formats also. See here, in this example, this is your data. So total number of samples maybe 31 is there. First attribute is duration, date, pulse, max pulse, calories kind of information is there. So here 22nd row and 26th row. 22nd row is the null values, means missing data. And 26th day data is there, is not appropriate format, because this is the data but is not in the date format, right? So you can bring into the appropriate format depending on your attribute and your data attribute values. Okay, so for example, this is the attribute is related to the date. So now I bring the all the values into the date format. So here, so date time format, to underscore date time function is there. So what will happen? Where is your attribute is date attribute is there. So that will be converted into the date format. So in that case, what will happen? You can see where is the 26th row. Now it is converted into the date, but 22nd is not converted. Okay, it's a not yet time because it is a null value. So what is given? It's not a time, but is the date, but not given the date format. Now you are using the date time function, then it converted to date. So this is a like a null value kind of thing. So either you can, I said, in this date kind of applications, we not take the mean or median kind of approach to handle the missing values. Simply you can, what you need to do, remove the row in that case. Okay, so like that you can drop the row of your particular attributes where is the null is there. So in that case you can use the particular drop NA, where is the null values is there, it will be drop that row. So which attribute? Date. Okay, in place true means that row will be removed, so applicable to the your table. Okay, so this is some where is the attributes not have the proper format, you can remove that particular kind of the attribute values, means rows kind of thing. So next final one is the feature engineering techniques is there. So feature engineering means I am saying attributes or features or properties. Then how you get these values? Already you said you have the some CSV file is there, in that you have that this data is there. But really that values directly you can get it from the each and every application? No. Sometimes you need to apply some techniques on the your raw data to get these values. Okay, so that is the, you can call as a feature engineering kind of thing. Okay, so that feature engineering we can go, either we can go for the feature encoding kind of techniques. So basically this feature encoding techniques is apply for the text related data, and this is mostly first two are used for the image related data, and this is for the signal related data. Okay, so this already we seen normalization standardization kind of thing, and we this is the binning means remove the noise information kind of thing. You can see the binning technique kind of thing. So now we need to see the feature engineering kind of techniques using these two. Okay, so what are the common type of the data is there? Features type of the data. So already one type you can see numeric. So it is contain the numeric values. So numeric values means some quantity of the variable. So it is a measurable kind of thing. Okay. So basically this numeric values are two types. One is the continuous and discrete. Okay, so maybe it is continuous means it is the maybe infinite kind of possible values is there. These are the quantity kind of thing, already measurable kind of thing. Okay, so that is a numerical values. So for example, you can see numerical person age, salary, height. These are the numerical values kind of thing. So that basically two type. One is continuous data is there, discrete data is there. So in case of continuous, it is consists of infinite possible values. So any value within the specified range, it is contain any value. So that is measurable kind of thing. So for example, height 5.72, 6.03, particular range, you can take any value, maybe 6.73 or maybe 5.74 or 7.45 like this, 5.75, any value, particular range kind of thing. So it is a quantitative variable kind of thing. Next, descriptive kind of thing, it will take the specific count kind of thing. Okay, so it is countable. So here it is, you are not counting, just you can take the some specific value kind of thing. Value means like 5.72 or 6.03 or 6.15 like that. Next, countable means you can take the 1 2 3 4 kind of thing numbers, like number of children 0 1 2 3 4, or number of cars in your household, and goal score, how many goal score. So this is the like round values kind of thing, and count values, how many children is there, how many cars is there, like that it is count. So this is the discrete. Okay, but this is the continuous kind of thing, but it's the numeric values only, numbers kind of thing. Next, another type of the data is the categorical data. We already seen what is the categorical data, where the labels kind of is there, that is called the categorical data. So categorical data, two types is there. One is called the nominal data, another one is the ordinal data. Okay, so nominal data means it not follow the any order kind of thing, no need of any order. So ordinal data means it will follow order, particular order, but it is a label related. So means labels kind of, category means labels kind of thing. See, nominal means it's not any kind of order or ranking will not follow. Example, gender, male, female, non-binary, other is there. Eye color, blue, brown, green, hazel. Country, USA, Canada, Brazil, India. So in this case, maybe India will come first or Canada will go last. There is no sequence or no order kind of thing. Or male, instead of the male, female will come first or male will go last. There is no order, but these are the labels data we can call as a categorical data under the nominal. Next one is the ordinal, means what? It follows specific order. So for example, you can come from the order like this, either like this or like this: poor, fair, good, very good, excellent. So you can't say poor, excellent, fair, like this. We are not go, you can follow one sequence kind of thing. Even your degrees also, how to specify: first school, like bachelor degree or btech or anything, or master degree, mtech, or next to phd kind of thing. It will go either this way. Our movie rating also, 1 2 3, one sequence we can follow, order will follow. So but here what is your kind of thing, it is the labels kind of thing, information is there. Okay, so this is one type of the data. So when we see the numeric data is continuous or discrete is there. Next one is the categorical data. Categorical data means it is a labels, it is a nominal variable or order variable. Nominal variable is not follow any sequence or any order kind of thing, means any ranking kind of thing. So another one is the ordinal, it is follow particular order kind of thing. Another type of the variables is binary features. Okay, so binary is consists of a two values, yes or no, or 0 or 1, like this is there. Okay, so that is the binary features. Next, text features is textual related, text documents related. So they apply the tokenization kind of thing, split the each sentence into the words will be represented with the characters, and each one have the some specific kind of vector representation, so that we can see how they will represent the text features. So normal text features represented with the one hot encoding kind of mechanism. So where is the word represent the, or letter represent the, that given as a 1, remaining you can given represented with the zeros. Okay, so for example, this is my sentence. Okay, so now you want to represent with this word, then this word position is given as a 1, remaining positions of the words given as a 0. So like this, I. So I is the first position word, then first is given the 1, remaining all are zeros. And love is given as the second position, then in that position given 1, remaining all are zeros. And my is the third position, remaining all zeros. Dog is the fourth position, only in that place you can give the 1, remaining all are zeros. So like this we can represent with the bits. Okay. So this is the this entire vector representation of this sentence. Okay. Like this, how much size is there, how much size is of the sentence is depending on the number of words in the sentence. How many words is there, that many bits we can get it. So this is the we can call as a one hot encoding. So another text representation is called the bag of words representation. So bag of words representation means, for example, here in the name itself we have the bag is there. Okay, bag means some words which are the famous words is there or frequent words is there, that words only you can consider. So the words will be represented with each word will be represented with the in each document. How many times is occur, that frequency you can take it. For example, you have the 10 documents is there. So 1, 2, 3, 4, 5, 6, 10. You are collect the some words which are the frequent words or maybe specific words kind of thing. So that first one word is selected. This word how many times is occur in the first document. The frequency count is taken like 5 times, 2 times, 8 times, 4 times, 1 time, like this. The frequency is taken. That is you can apply in this bag of words. Then this entire vector is considered as a feature vector. This entire one is considered as a feature vector. Okay, so that is the bag of words representation. Okay. See here an example. So this is the your sentence. So that sentences is arranged IDs. How they arranged IDs? Alphabetical order. So for example, here starting with in this sentence, cool is starting with the first one. So index is 0, and I is the second letter. So index is 1. L is the next after I, L is there. So index is 2. Like that index, based on the index what is there. Next you can they will take the count. Okay. So each one how many times is occur in that document. For example, is a cool. How many times is occur in this? Only one time. So 1. Next index is how many times occur? This is also one time. 1. Next is the love. So this is the how many times occur? 1. 1 is taken. And next index 3. NLP. How many times is occur in this? 2 times. So count is 2 is taken. So next word what is there? 4th. So how many times is occur? 1. So like this, for the given a sentence, they form the feature vector. This is a feature vector for the that sentence. So another way of representation of the text document is that is called the TF-IDF, term frequency inverse document frequency. Okay, using this TF-IDF. First one is how they will text document is represented. One is the one hot encoding mechanism. So where is the word occur in that place? So they will take one remaining words. They will represent it with the zeros. Next one is a simple bag of words. Okay, so that word how many times it is occur in the document, the count is taken. Now that is called the term frequency, TF. So here they use along with the term frequency inverse document frequency. It's just a normalization kind of thing. So what is the term frequency? You can say term frequency is nothing but the word how many times occur in the document. Okay, inverse document frequency is nothing but the total number of documents how many is there. In the total number of documents, what is the frequency of the word? Just normalization kind of thing. So n is the total number of documents in that one. So that word is how many times occur for total number of documents. So that is multiply with the term frequency, that is called the TF-IDF. Okay. So based on this is the we can form the feature vector of the your sample. Okay. So this is the text related kind of thing. Another kind of thing, image related. So image is nothing but what? It is the two-dimensional data. It look like a matrix kind of thing. Two-dimensional data means it is a matrix kind of thing. So how we are visualizing this image or shape of the object based on the some kind of information that is called the pixels. So based on the pixels, we are seeing the some shape of the object, visualizing the object. So what is the pixel? Pixel is nothing but the some intensity value or frequency value. So based on the pixel intensity values or frequency values, we are visualizing the some shape of the object. For example, this image is the binary image. So binary image is nothing but is contain the only black and white color kind of thing. Either it contain the black color and it's contain the white color. So where the block indicates the intensity value is 0, white indicates the intensity value is 1. So the entire image is represented with the zeros and ones only in the binary image. Suppose we are selected a small portion here, that is extracted the small portion. Okay. So where the white is there, it's contain the 1 value, where the black is there, contain the 0 values. So these are the pixel intensity values. So based on the pixel intensity values, we will make it as a feature vector for the images. Okay. Suppose my image size is 10 cross 10. Okay. You can assume each cell is the 1 pixel. So total how many pixels is there? 10 cross 10 means 100 pixels. So each pixel contains the how many value? 1 value. What is the value? Either 0 or 1. Where the 0 is there, it is contain the black color. Where the 1 is there, it is contain the white color. Okay. So like this entire image contain the ones or zeros kind of thing. So total how many values for this 10 cross 10 image? Total 100 values is there. Okay. So this is the binary image. Another type of the image is the grayscale image kind of thing. It is not the binary image, it's contained along with the binary, means along with the black and white is contained the gray value. So it is also image, means it is also two-dimensional data. So it contains the rows and columns kind of thing. For example, here also you can assume it my image size is 10 cross 10. So 10 cross 10 means how many values is there? 100 values is there. You can assume it each cell is the 1 pixel. So each pixel contains the how many values here? Here also it contains the 1 value. What is the value? The value is ranges from the 0 to 255. So which are the 0 to 255 means 0, 1, 2, 80, 81, 254, 255. Like this values is there. So which are the pixel values near to 0? It's look like a black color. Which are the pixels values near to 255, 254? Like that is there. It's consists of a white color. Remaining all are depending on the thickness of the gray. Which is more gray color, then it's towards the 0. It is light gray, then it's towards the 255. Okay. So now we can say here if I selected one pixel, what is the pixel intensity value here? It look like a white color. So it's not pure white, but it's white color means maybe it is 250 or something. Suppose if I selected one pixel here, what is the pixel intensity value? It is almost look like a black color, maybe it is 4 or 5 value. Suppose if I selected one pixel here, then what is the pixel intensity value here? We don't know exactly because very difficult to we can identify. Based on the thickness of the gray, the value will be how the frequency. So maybe it is more gray, it is towards 0 or maybe 30, 40 or whatever it may be. Okay. So this is a binary image related kind of data. Next, another kind of image is called the color image, which are we are regularly using image. So this is also one image. So for example, here also my image size is 10 cross 10. Okay. So it is color image means each pixel you can assume as each cell you can assume as a 1 pixel. So each pixel contains how many values here? 3 values. Previous case 1 value, but here 3 values RGB. So each value contains what is the range from the 0 to 255, 0 to 255, 0 to 255. Suppose if I selected one pixel here, then what is the pixel intensity value here? So each pixel contains how many values? 3 values RGB. So it is not look like a red, maybe it's near to 0, 4 or something. It's look like a green. So it may be 250. It's not look like a blue. Maybe it is the 8 or something. So the 3 color combination, it is appeared as this type of the green color. Suppose if I select one pixel here, the flower. What is the pixel index value? Red, green, blue. It is not red, maybe 30. It is not blue, green, maybe 85. It is not blue, maybe it's the 42. So this 3 color combination, it is appeared as a yellow color. Okay. So like that, each pixel contain the how many values? 3 values. So previous case, you can see total how many values is there in the binary image? 100 values. Suppose if I use pixel intensity values, means the frequency values as a my feature representation. What is the feature vector size? Pixel intensity values as a I use as a features, means first row values, second row values, third row values, fourth row total how many? 10 rows. Each row how many? 10 values is there. Then what is the total size of the feature vector? 100 cross 1. Here what is the values is there? This values is nothing but pixel intensity values. So in the binary case, what is the values is there? 0 or 1s only. Now come to the second type of the image, grayscale image. So here also I want to form the feature vector for the my image data. So in that case, if I use the pixel intensity values as my feature representation, total how many values is there here also? 100 plus 1. First row 10 values, second row 10, third row 10, 10th row 10. So but what is the values here? Previous case zeros and ones. Here zeros and ones are other values. No, it is depending on the thickness of the gray. 0 to 255 value is there. Now come to the here. If I use the feature vector for this image data 10 cross 10, then how many values is there here? Previous case 100 cross 1, binary case 100 cross 1, grayscale case. But color case how many? 300 cross 1. So what is the size here? 300 cross 1. Why 300? Each pixel contains 3 values: red, green, blue, red, green, blue, red, green, blue, like that is there. Okay. So total 300 values is there. So that's the reason it is a 300 cross 1 vector. Okay. So now here, how to represent the image? The represent the image is height, width, color, the image channels. So in the binary case, all the cases my image size is 10 cross 10. So what is the height of the image? 10. Width of the image 10. How many channels? Only one channel, means each pixel contains the only one value. Grayscale image 10 cross 10 cross. Here also only one, because each pixel contains the one value. Color case 10 cross 10 cross 3 channels, because each pixel contains 3 values. Suppose if I separated all red color pixels and make it as a matrix again, then what is the matrix size? This is also 10 cross 10, because each pixel contains the only one value, that is the red values. So you can project this as the image. Then how it is look like? So what are the this objects is there in the image? All the objects appear with the red color, because I separated red color pixels. Suppose if it is I separated blue color pixel values and projected as the image, then how this image is look like? Blue color. What is the size? 10 cross 10, because each pixel contains the only one value with the blue information. Next, I separated the all green color pixels and projected as the image. What is the image size? 10 cross 10. So each pixel contains one value. What is the value? That is the green pixel related information. If you projected this as the image, how it is look like? The entire objects are visible with the green color. So this RGB we can call as the channels. Okay, red channel, green channel, blue channel, or maybe red band, green band, blue band. So like this. For example, this is an image. Maybe you can assume is 100 cross 100. So that is just zooming and zooming and zooming. Finally, the shape of the object is disappear. Only numbers will be appear. Okay. So the numbers you can see. Based on numbers, can you tell me it is a binary image or grayscale image or color image? First, you can identify each pixel contains the one value or 3 values. See, this is each cell is the one value is there. So it is not contain the 3 values. Not contain 3 values means it is not the color image. Either it is binary image or grayscale image. So binary case it is contain only zeros and ones. Gray means 0 to 255. See here 237 is there, 214 is there, 239 is there. So it's not binary, it is a grayscale image. Suppose you have the color image is there. I said all the red color pixels separated of, for example, 10 cross 10 image. So this is also 10 cross 10, then projected as the image. Then how it is look like? The same objects will be appeared with the red color. The same objects will appear with the blue color. Then same object will be appear with the green color. These are called as the RGB channels. Okay. So for a given image, you can represent with the frequency. Frequency means intensity values. Then that is called the frequency graph. So first pixel, how much frequency value is there? Second, how much frequency? Third, how much value? Fourth, how much value? So that is you taken the x-axis is the number of pixels and y-axis is the what frequency or intensity value. Then you can plot it as a graph. Okay, that graph we can call as a histogram of the image. Okay, so like this, the pixel intensity values taken as a feature vector and they apply as a machine learning techniques or any other kind of thing. Sometimes what they did, instead of taking the each individual pixel values as a feature representation, they will consider as a bins. Okay, bins means, for example, the divided into the pixel intensity values into the particular range 0 to 20 means equal interval ranges, means 20 different range they will take it. So like this pixel intensity values taken as a equal interval range. So our image start from here, first pixel, second pixel, third, like that total 100 cross 100 pixels is there in this image. Okay, now here instead of taking the pixel intensity values as a feature representation, what they will take a pixel count, frequency count. So 0 to 20, 0 to 20 frequency, how many pixels is there in this image, the count is taken. For example, 0 to 20 pixels frequency, maybe 30 pixels is there, so 30 is here. Next 20 to 40 frequency, how many pixels is there in the image, 18 pixels is there, they will take an 18. 40 to 60, maybe it is the 24 is there. 60 to 80, maybe 45 is there. Like that, how many pixel is there in that frequency, the pixel count is taken. So the count is arranged as a feature vector, like 30, 18, 24, 45, like this. This is used as a feature vector. Okay, so like this they use the color based feature representations. Okay, so now we can see here, suppose have the one red color apple is there, one is green color guava fruit is there. If I use pixel intensity values as my feature representation, can I discriminate these two images? You can ignore this leaf. So this red color means you can draw the frequency graph for this one RGB. So it is contains more red and green and blue almost 0. If you apply for the frequency graph for this guava fruit RGB, so red is 0, green is more, blue almost 0. Then compare these two histograms, both are similar or different? Different. So based on this color, we can easily discriminate these two fruits images. Suppose here one red color apple is there, one red color Thai car is there. If I use my color representation as a feature, color means pixel intensity. Okay, so based on that, can I discriminate these two images? You can assume both are the same red color. So here you can take the RGB frequency graph, red is more, green blue 0. So here also red is more, green blue almost 0. So both are look like a same histogram of the image, means same histogram is same class, but really same class. This is a fruit related class, this is a Thai car related class. Then in this case color will won't work. Then what type of features I need to use it? Shape. The shape of the apple is round shape and the Thai car shape is different. So shape related features you need to extract. Okay. Next, for example, one red color apple is there. You can assume it same red color ball is there and same shape is there. Both are shapes also same. Now if I use color, can I discriminate this both? Not possible because both are red. And shape, this also not possible because both are the same shape, round shape only. Then how can I discriminate these two images? Texture. Based on the texture of the apple is different, texture of this ball is different. Okay, So like this, use the texture features that we can call as the GLCM features, gray level co-occurrence matrix, like entropy, mean, median, skewness, energy. Like this, we can extract the some values. Okay. So this is the feature engineering related on images. We see in text related feature engineering, we see in the image related feature engineering. So like that, many techniques or methods are available. Okay. So if you have any queries, any doubts is there, you can ask here. Any doubts? So okay, no doubts or no queries, then we can close the session. If you have any doubts is there, you can ask, otherwise I will close the session. Yeah, maybe some programs we can conduct in NID Varangal also. Maybe if you're interested, you can join. You can check the website. In the website, one workshops tab is there. In that workshops, they will update the every what type of the workshops is going on. You can see and you can apply it. Yeah, sure. Yeah. So any doubts is there, you can ask. Otherwise, you can close the session. Okay, I'm closing. Thanks to all.